I will first go through with a couple of slides of other things that we are doing, have been doing in the project, and then go into the issue itself. So we are looking at districts, and of course one of the things that we have to find out is what are the barriers for district level refurbishment. And to find out that, we had a lot of interviews in different countries, and probably Tarja will tell about those a little bit in her presentation. Then the other thing is that district level refurbishment strategies. We have developed, for instance, delivery models to carry out large and very long-term projects to refurbish the districts. One of the things is also I have to turn to look at, because I have only my reading glasses with me, so can't find it. Design and decision-making methods and tools. This can be analyzing tools or such. Also processes and business models. Tarja will also talk about those. And then energy optimization and impact, and that's why we have also developed a lot of different simulation tools, different design methods to find out best ways to tackle the problem. And then we have case studies, and I will talk about those a little bit. So first, the tools. The first one is APROS. That's a dynamic simulation tool originally developed for energy production processes, but now VTT has added into it the buildings and also the energy distribution networks. And that then helps, of course, to analyze very accurately actually the performance of the whole system, and how the different actions to be made will impact on the emissions. The energy system design method, this is a Siemens tool, and that aims at kind of optimizing the energy production system as a whole for a city, and we will have also a presentation on that. Then the GBR real estate, this is the Dutch tool, and the aim is really not to look at the building level, what happens on the building level, but on the larger scale, and how measures that can be added to several buildings then can impact on the total emissions. And then a German tool called the District Energy Concept Advisor, and this is a very early stage tool for a very rapid decision making, so that using, for instance, building archetypes, you can very rapidly or easily get the impacts on emissions through the tool. Then these are the case studies. We have two in Finland. One is city of Suonejoki. We have the city center, so to say, included into it, some 180 buildings and roughly 7,000 people living in this area. Then we have the Daugavpils, that is in Latvia. This is the largest of the case studies. Should be something like 14,000 people living in there, and roughly 200 buildings as well, multi-story apartment buildings. Then we have Kranj, which is a small town in Slovenia, and the area, it has some 90 buildings into it and roughly 1,100 people living in the area. And then Riihimäki, Peltosaari in Finland. This is of course a case study that has been looked at in very many other projects as well, but this is why we have it, because there's a lot of basic information and also results that we can utilize in comparing issues, and specifically the process delivery models. Then we also looked at how this can be done. This is of course a long-term project. It's a big project typically. I think that we estimated already some years ago that, for instance, if we would like to refurbish the whole Peltosaari area, it would be something like 80 to 100 million euro project, more than 1 million euro per building. But we looked at the alliance or public-private partnership, or private-private partnership project, or kind of a distributed design build or primary project would be those that fit into the district level refurbishment projects the best. And the primary project means that there is one strong player who wants to refurbish the properties that they have, and then they are inviting other people to join. It's a little bit developed version from a so-called group refurbishment. And the distributed design build is, of course, it's a design build project, but it's distributed so that each of the buildings might have their own design and construction refurbishment process, but the procurement, for instance, can be common. And then one more thing is the kind of what the social consequences of district level refurbishment might have. Of course, if you have an area where are different families with different levels of income, the improvement or upgrading an area might also have then negative social consequences, and this is what we also studied. So that if the purchase prices or rents are going up in the area due to the refurbishment and upgrading, that means that then maybe the low-income families have to move, which means then that the whole area is getting more like a more middle-class area. And that is not, of course, the thing that we wish to have as a result. And then also, this is called gentrification, I believe. I don't see it, but it says probably so. But then the end user advantages as well, that of course there are the technologies and there are the incentives how to do it, but then there are also the attitudes and how people think about it. And to have a successful project, then those have to meet the people's attitudes that they are happy with the refurbishment. Then about the city information model, of course, you have all seen 3D models of cities a long time already, but here the information model means that there is also information content for each of the buildings. And our aim with the information model is that you can use the information that is embedded into the buildings also in energy analysis or for also other purposes as well. This is not a very difficult to do if you have the laser scanning data of the area, then you can just use the point clouds that the scanning is creating, and you can get the locations of the buildings and right dimensions for the buildings. And then if you have it in somewhere in the cloud, everybody can also add the information into the system. So it's not, you can do it by drone nowadays. I think that you don't have to even have an aeroplane or a helicopter to do it. So kind of the prices of the laser scanning is going down. In Finland, I think it's quite easy because most of the country has already been laser scanned, and that's why the information is available if you only can reach to it. So when you have the model, there are several different services that you can then use or where the sim is useful, one being, of course, the energy simulation, but also you can use it for flooding analysis, or you can use it in pollution dispersion. You can use it for wind comfort analysis for the built structures. And up to some extent also, if you want to calculate the wind forces against the buildings, then you can do it. But of course, there's also competing method is the wind tunnel tests. But you can do it. And but when you are doing this kind of an action and you have it's a big area, you have a lot of modelers over there, then somebody has to coordinate that the models fit to each other. It's kind of the same way as in the building information modeling, that when the designers are designing building, then somebody has to coordinate that each of the model fits to other models so that there are no conflicts. Now there's also a short video here about what it means. So this is now the city center of Suonejoki, and first we look at how the energy-wise we can improve the area. The scanning here gives you the buildings. It gives also a terrain for the whole area. It gives the vegetation over there, but you can remove the vegetation, so then you have only the basic terrain area. So we have in the model the district heating network, not all the smallest branches, but almost all. These are images of the laser scanning. And then the model can be like this. It doesn't have to be rendered buildings, just boxes or whatever the building shape is. But the information content of these buildings is the most important. And then you can make scenarios whether you want to put a PV on the roof or somewhere else, and is it possible, is it worth putting over there? And then using this this model for different simulations, like district heating consumption in the buildings, and what is the losses in the district network, and what is then the final demand that includes all the losses from the processes as well. Also visualization for the designs, what it would look like if you add photovoltaics in the buildings or other renewable energy schemes. It can be also outside the building structures, and then you can also use them as an architectural components. So, just an example also on other uses of building information modeling, and this is flooding simulation. And this is a way how to kind of prepare for possible floods, and what kind of extent they have, and how much or what kind of damages it can cause. And then on the other hand, you can also look at how to prevent the damages. So this is a river and a small lake in the river. This is also in the Suonejoki area, and you can see that if the water level rises like 1 meter, there's a lot of areas underwater. Also roads are underwater, but they have been wise enough there and built the buildings, the city center, so high that the flood cannot reach them. That was my presentation. Thank you.
Thank you so much, Jyri. How was this model taken in the city of Suonejoki by the city planners?
Well, the model itself is of course good, but it doesn't bring as a model for the city planners much, because they already have the plan and they have the buildings. But the importance comes probably from the other services that you can embed with this, to bring with this model. So the energy simulations and pollution dispersions and that kind of things. And in very many cities we already have a 3D model, but I don't know how far it has been used then.
Okay, is this something that that can be taken into use in basically any city, or
Everywhere.
how is it?
You can use it in the countryside or in the city. As I said, that it's not so complicated to do the model. If you don't want, if it's enough that you can show the where the buildings are located and what is the shape of the building, but you don't want to show the rendered facades.
Thanks for the video. It was also very concretizing very well
Thank you.
what you have been doing. Thank you once more.
Yep, thanks.